My name is Joe Cernik. I'm a member of the faculty here at Lindenwood University in St. Charles, Missouri. This is a show called Insight, where we usually discuss books on politics, both domestically and internationally. Sometimes historical perspective books that provide some insight into the present. Sometimes books such as the one we're looking at today, which provide sort of political issues in a much broader setting. And so this book, written by Jeffrey Bennett, is called A Global Warming Primer, answering your questions about the science, the consequences, and the solutions. Now, joining me on the show today are two Lindenwood University students. To my immediate right is Maria Sanchez, and to Maria's right is Eric Bideri. And so I wanted to read an opening quote from the book, and then we can jump into a discussion about it. Okay? The author writes, "Is human-induced global warming a real threat to our future? Most people will express an opinion on this question, but relatively few can back up their opinions with solid evidence. The truth is, the basic science is not that difficult. Sure, Earth's climate is complex, and therefore we see so many details of the science of global warming, but I can tell you from my own teaching experience that the key ideas are understandable to most fourth and fifth graders. One of the primary problems with science education, both in the United States and globally, is that we too often allow students or the public to get hung up on details before they understand the key big picture ideas. Global warming offers a prime example because the media debate is filled with endless arguments about topics like the intricacies of computer modeling or climate feedback, even while the basic science is almost completely ignored."
Yeah, this quote was extremely comforting to me, as in the sense that I do not study or specialize in great detail chemical or biophysics science, so it was really encouraging to realize that I can actually understand some of the basics, and it brought upon a lot of realizations among myself, in the sense that my personal belief of I know there's something negative going on in the environment and just blindly supporting it. And so it kind of also brought me into that I do support some ideas without even actually backing up any of my claims or being able to explain why some things are happening in our environment. So it was really encouraging having this to be the first opening quote of the book.
Yeah, I can agree with the quote itself, because I, for one, was someone who was beginning to believe that global warming and climate change were just things that people were putting out there so people can just be more aware of the environment. Yeah. But reading it, I realized that it's actually something that is happening. It's imminent, coming in the future. And the reason to why I think people are not considering it a threat right now is because, as the way the author had said, it's our grandchildren that will be the ones who face it. So I think people right now are just very relaxed in dealing with it, because they're like, it's not going to happen in our generation. So they're like, we'll leave it for the people of the future.
He has his opening chapter was called "The Basic Science, Easy as 1, 2, 3," and I thought that I went through that, and it's readable. I think you sort of read science, if you're not acclimated to reading science, it's sort of, you have to stop and think slowly about it. So even though he's trying to make it understandable, it still takes a little bit of thought process to understand it. But he started off that first chapter, and he says, well, more than a quarter century ago, we were recognizing global warming, and he had these two quotes, one from Margaret Thatcher, who was then the British Prime Minister, and she wrote, what we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. And then he quoted George Herbert Walker Bush, and again 1990, so both of these quotes from 1989, 1990. We all know that human activities are changing the atmosphere in unexpected and unprecedented ways. So he was trying to show with these quotes, and then led into that first chapter, that okay, we're spending now a good half a century, a quarter century rather, of looking at issues, and as a result they're not going away. And so that notion of just ignore it, no, it's she's trying to show, no, not a good thing to do.
Yeah, and it's really good that he opened with that, just to debunk this whole myth that it's a right and left-wing issue when it's really not, because we see these two conservatives that are addressing the changing environment, and it's something that on both sides we can't afford to ignore anymore, because it's, as you said, it's gonna, because we are not seeing it physically, or we're not seeing it, it's not really as tangible as it's said to be out. Their grandchildren are going to feel it, so we have to address it now and more than later.
Yeah, I really like how in the whole book, every chapter when he opens up, he tries to show that it's not something that is just from conservatives and or a liberal idea. It's everyone agrees with what is happening. It's just that no one is taking any direct action towards it.
Yeah, he at the beginning was trying to explain how to sort of understand this issue of warming related to the issue of carbon dioxide. And so he says we're going to look at Venus and Earth, and okay, Venus is closer to the sun than Earth, but the difference is how carbon dioxide as a gas is trapped, creating a heat on the planet. And so the Earth has just enough carbon dioxide to make it livable, but in the case on Venus, it has too much to make it too hot. So he says, so they're both about the same size, close to the same size, but the difference is that heat related to carbon dioxide, and even though Venus being closer to the sun, it's technically not just because it's closer to the sun that makes it a warmer planet. It's that issue of trapped carbon dioxide.
And I really appreciate the analogy, because carbon dioxide was just something that has been thrown out without explaining what it's doing. And for someone that just doesn't really read in great detail of carbon dioxide and its effects, it was really nice to just having it being explained in a simple term that now I understand why carbon dioxide is dangerous. And it's not that it's just altogether dangerous because that's what I used to believe. It's just because it's been thrown out and it's being associated with a negative connotation. I just assumed that carbon dioxide in whole was bad. And it's not, that it's just having too much of it, as he explained that without carbon dioxide, our planet would freeze and it'd make it unlivable. And with too much, we see with Venus, it makes a planet unlivable because it's too hot and carbon dioxide is trapping heat. And so it was really nice having this explanation of seeing it in perspective in Earth and Venus and being able to explain it to someone who really didn't study in great detail.
Yeah, I really like how he compares two planets that are very, very similar, not too far from each other. And the difference is 200,000 Newton meters or something of carbon dioxide that are in Venus. And that just makes it 470 degrees Celsius average temperature versus Earth where it's 15 degrees Celsius. And if we didn't have how much we have, it would be minus 15 degrees Celsius, the average temperature. So it really shows how much carbon dioxide is keeping our atmosphere and the temperature at a very constant level and livable amount.
And that's what's changing, because his quote is, it shows that gases like carbon dioxide, which we call greenhouse gases, really do make planets warmer than they would otherwise be, and that the more of these gases a planet has, the hotter it will be. So as a result, then you're looking at, we need a certain mixture of carbon dioxide, but if we get too much, that's part of the problem. And then he's saying it's occurring naturally, but it's also occurring because of human activity, and the human activity related specifically to the use of fossil fuels, so coal, gas, oil. They're all releasing carbon dioxide, and then by this burning, you're now having an increase in a heat-trapping gases remain, which are causing a large part of the problem.
And I like his also just explaining again, because for some reason, I know I had a confusion over this about carbon dioxide being exclusive to greenhouse gases, and it was really nice to just see that they're actually interconnected, and the carbon dioxide is a greenhouse gas. And so it's really nice to see that it's a one issue that, again, that traps heat, and the greenhouses is something we need to address. It does occur naturally, and it has been occurring naturally, but we're rapidly increasing the creation of carbon dioxide, and it has to do with a lot of fossil fuels, which is also nice that he explained that, because carbon is a base of life, and so when we're burning it, it mixes with oxygen, thus creating this carbon dioxide that we are creating, and so it's really nice to see that explanation.
Yeah, I think we need to look back to where he says that too much of a good thing is a bad thing.
Yeah.
So carbon dioxide being a greenhouse gas, and a greenhouse gas is just a gas that traps heat. So because enough of it is good, which is why we're here, and we're not in absolutely freezing temperatures at all times. But having too much of it is a problem, and that's when all these things of burning fossil fuels and all other activities that humans are doing, which is just adding more to the carbon dioxide that's expelled into the atmosphere, makes it a bad thing. Because the Earth naturally in itself has an amount that it puts out, but when we start adding our own, we're just adding excess.
Yeah, and it's also really nice that he also referred to other greenhouse gases, which I've just myself, I think, completely ignored other than carbon dioxide, and realizing that water vapor, H2O, and methane are also part of this. And it's not as, he really does emphasize on carbon dioxide because it does put a lot of weight up to how other gases increase, but it's really also just great overall, just seeing that water vapor and methane and other halocarbons come into play, and just seeing that it's all interconnected process of how we burning fossil fuels increases water vapor, and these water vapors do also trap heat, and so it's really nice to just seeing that perspective.
Yeah, his sort of basic point here, I think, is we should expect the rising carbon dioxide concentration to warm our planet, with the warming becoming more severe as we add more carbon dioxide. So he says the more greenhouse gases that are present, the greater the degree of surface warming. And so again, how he is trying to explain how it is that we're looking at this. And so he goes on again. He had this whole thing like you were just talking about, breaking down greenhouse gases into these different elements so that we begin to see a relationship between the surface, the water. He calls it reflectivity, so that you're going back and how you're looking at a change, that it's getting even colder in the upper atmosphere than it used to be.
Yeah, also, again, with the carbon dioxide, just seeing how it's a good thing, and it's bad if we have too much of it, and how our planet, like when he uses the analogy of Venus and Earth, of just explaining why carbon dioxide works with us, and seeing that it ties in with our oceans, that carbon dioxide dissolves and it's being, as he puts it, locked up, and so it balances out almost for us to not have excessive carbon dioxide in the atmosphere as it does in Venus. Just seeing that a lot of this process is really one whole thing, is not exclusive things, that it's just we need to tackle this one issue of carbon dioxide, but really it's affecting our oceans too as well, so it's really nice seeing that.
Yeah, he said something about the Earth being soaking in the heat. It absorbs the heat and it radiates it slowly through infrared, just like humans do. We all release an amount of heat, but I guess the smaller bodies just don't show it, and Earth in itself and the oceans and whatnot, the way they release their heat from the carbon dioxide that's coming in, more of it coming in makes them create more heat, which just in turn reverses, it makes a whole cycle happen And it's just, there's no way out if you keep on adding carbon dioxide into it.
Yeah, and as one thing that he addresses that I had a question too is, how is this heat staying on our planet? Because just from things I've learned in other past educations, that it goes back, that the sunlight comes in and then eventually it has to go back to space. And it's, again, that these carbon dioxide and water vapor and methane and other gases are trapping it, but they're still going back. It's just that the process is so much slower for them to go back, which is why they're able to make our planet hotter and warmer, because they're going back so slowly because they're trapped, the energy's trapped. So yeah. I thought it was interesting in that sense.
Well, and also how he talked about that Venus, the heat is partially because there are no oceans, whereas Earth has oceans, so that it prevents us to have the right amount of temperature, why they're not having it on Venus, and so why it's able for humans to live here but not there. So then again, he's going on, he says carbon dioxide is the most critical gas in setting Earth's temperature. So your problem is as you begin to alter that, then you create these problems. Right? Yeah. And so, you know, he addresses some of the other issues which I thought were interesting. He was talking about the idea that we could tell where Earth's temperature was in the past through ice cores. And as a result, what we do know is the concentration of carbon dioxide now in the atmosphere is greater than it was at any other time in Earth's history. And so, and he talked about the idea that we have to understand that we're taking the temperature at different places all around the Earth, so we're then trying to do an average, but then you're doing the same thing with how you're taking ice core samples.
Yeah, with the ice cores, it shows that there are spikes and declines in our carbon dioxide concentration, and it just kind of seems that, oh, we're just experiencing one of those spikes, that it's normal that we're seeing amounts of deep concentration of carbon dioxide. But I think with the putting in the perspective of 100,000 years, that these spikes is accumulating over 100,000 years, and with us it's within decades. So that's what should be the alarming or the concern of it, that it's happening at such an increased rapid rate that's unprecedented to what has been happening as he dates back 800,000 years ago.
And he backs it up with the graph of how it changes during the Industrial Revolution. During the Industrial Revolution, you start to see the spike in carbon dioxide just increasing, and that's about when, you know, the world started becoming more industrial, using more coal and other fossil fuels. And those ones with the ice coals, it's like the cores, it's showing that, like you were saying, it's just a natural thing, you know. And in the past times, it has gone up a little and then gone back down, but it has always been within a certain range. Yeah. But now it has increased by a significant amount than what it usually does.
He talks about that here, the concentration measurement. So he says the ice core samples going back 800,000 years, and that what we've always seen through those ice core samples is the concentration of carbon dioxide is what he says between 180 and 290 parts per million. And he says, but then things begin to change after 1750, which he's dating as the beginning of the Industrial Revolution, but then pick up from there. So he says, today we are at 400 parts per million, and that is significantly higher than at any point in the past. And then he says, if we extrapolate into the future, we find that the carbon dioxide concentration is on track to double its pre-industrial value in just 50 to 60 more years and triple by the middle of the next century. So, you know, his idea, seeing that you're going to look at then, if we're talking about it being 400 parts per million now, we're going to look at it as 1,200 parts per million, whereas pre-1750, you were looking at a range that's less than 290.
Yeah, and then there's, with that same argument, that skeptics come here, where that even prior to 800,000 years ago, we have reached this 400 parts per million. But I think what the author's getting at, that it's the species at that time were able to do it because it's a different environment, that there's different plants and animals that are adapted to a higher 400 parts per million compared to today, where we are different species, we have different environments, and our plants need different needs. And so that's when it should be alarming to us, as we have different needs than them. So we can't really compare because we're incompatible in that sense.
Yeah, he had that explanation of the problem of adaptation to warmer, because he's saying, wait a second, you can't do that because that was a whole different era, so different type of species were existing during those eras, so they're not the same as now, so it isn't just we're going to adapt. He had a chapter called The Skeptic Debate, which I thought was interesting. And basically in there he's saying that skeptics are not doubting global warming. What they're doing is sort of saying they're not accepting the magnitude of the problem. And so I thought it was an interesting way, because we hear the term global warming deniers. And so in this one, he's sort of saying, well, he doesn't want to call them deniers, that he's saying they admit we're getting warmer, but they're not seeing the magnitude of it. And then he goes through a whole discussion about why he believes that is so.
Yeah, so the first skeptic claim was that the Earth is actually not heating up. It's not warming up as we'd expect it to be warming up. And they're saying that the difference in temperature is about 0.7, 0.9 degrees in how it's changing. And it's very hard for them to gauge the true difference in the temperature, because there's a lot of places to cover around the Earth that change, you know. And for them to say that it's warming up completely, they would have to get temperatures from so many parts of the Earth to figure this out. So skeptics are somewhat saying that it could be warming up in some places, but maybe some places aren't, and you just haven't measured it, you know? So they're trying to downplay that part.
And one example he references the Greenland, where in the medieval times we had a region that warmed up extremely, so skeptics refer to that, oh, it's just normal, that we're gonna as they survive that, we're gonna survive this. But he points out that it was regional, that it only happened, it was a phenomenon that happened in Greenland only. But here, as he said, we have technology that are measuring all other aspects of Earth, and it's a global issue, which that should be more alarming, because it's not just a certain area that's affecting our planet, it's a whole global issue.
Well, he's trying to show that the water is warming faster than the land. And he said, so when they're measuring warming temperatures of the oceans, he goes, okay, in 1978, there was something called El Nino, and El Nino is sort of the shifting patterns of how you're looking at water movements and air currents. And as a result, you then made the oceans warmer. So once El Nino goes away, the warming of the ocean went down a little, he says. So, but that's more of a discrepancy than it's sort of, oh, see that, we're getting better, it's no problem, because then you point to that. And he says, no, you got to look at it in the context of El Nino. And so you've got to discount the idea of saying you're having these movements that are sort of fluctuating. The general trend line is still all upward.
Yeah, he addresses that with also extreme weather, that because we have rain and we start having these snow days, that global warming cannot happen. But the point that he does it's that they're extreme. Just here in St. Louis, we had we got extreme snow, and then global warming doesn't exist because of that. And so he addresses that issue, that these are indicators of global warming, because water vapor is a consequence of warming planet. So we have rain still, and they're coming at a more extreme levels. And we see, he puts a map where it addresses the areas where these extreme storms are coming in. It's around Florida and Texas and other islands that are experiencing, because they're closer to the water. So it's really nice to see that.
Yeah, it's very interesting how that's an argument that a lot of skeptics are using. They're saying, if it's global warming, then why is it getting colder in a lot of places, you know, much colder than it has been in years? And that's exactly what is happening with global warming, is that it's just creating an opportunity for more extreme weather, because he speaks about how the ocean now is creating energy so strong that in some places it can be like 13, 15 storms in a day, which are like of a high degree, you know, the highest degree possible. So it's producing so much power in joules that it's not only in heat, but it's just making everything extreme. So if it's going to rain, it will be an extreme rain. If it's going to be cold, it will be extreme cold. And that is a sign of global warming.
His quote here, "The evidence we've discussed is the product of the work of thousands of scientists who have dedicated their lives to obtaining accurate and reliable data and who have carefully examined both the strengths and weaknesses of the data. So unless you believe that these thousands of scientists from around the world are all coordinating some great conspiracy, there's no reasonable doubt about the fact that our world is warming." And so, you know, he's trying to address, and this is what you tend to see sometimes, is you find one thing that looks like an anomaly and we're going to suddenly discuss it. And then as a result, see that you can discount global warming because this is the issue right there. Yeah. This person made it all up. And you go, wait, it's a lot of people doing a lot of different things. Certainly all these ice core samples and trying to take temperatures all over the planet aren't being done by one or two people.
Yeah, and I really agree with that. And also to look at just beyond the obvious that there are other factors coming into that we should look at as a sign of global warming. He also mentions that coral reefs are an indicator that has been, for the most part, ignored, that it's happening and whatever, it doesn't really matter, but it's an indicator of global warming that our oceans are warming and ocean life is being affected. And he goes into this with consequences, just seeing that we're going to start feeling it now, even within our own generation.
We only have a few minutes left, so what do you think of this book, and are you recommending that viewers read it?
Oh, I recommend it as someone who doesn't really emphasize in detail or great study of science. It was really nice to just be able to finally support at least my personal stance of environmental changes and just being able to explain of how things are happening and why things are happening, at least at a basic level.
This book definitely made me more cautious about what I do in life, you know, because I feel like before reading it, my normal life, I just ignored a lot of these things, but now I feel like I'm going to be more into what's going on with the earth and trying to take care of it as much as I can. And it's a very interesting and easy book to read because it gives you basic facts, scientific facts that are not hard to understand, and it just keeps you learning and learning until all the way till the end. And it's just a great book to read with everything.
Yeah, I thought it was a readable book, and I'm not big into reading a lot of science. And so, but the way he does it is he has a question, and then he answers the question, and then another question and answers that, and then a lot of charts and diagrams so that you can see stuff and figure out what it is. And so, yeah, you still have to take your time to think through the book, but a good book. So thank you for joining us today.